Alright, so I think this is recording, but I never know because I've been having difficulty with this lately. Alright, so let's take a look at this problem. Again, we're looking at polynomial functions. We're using this rational zero theorem. Rational root theorem is also what it's called, to help us find the factors, to help us find where this graph intersects the x-axis. So the theorem tells us to look at the factors of the constant term. The factors of 6, I've got 1, 2, 3, and 6. Well, obviously plus or minus on each of these. My leading coefficient is 2. That's a prime number. That's a sub n is the name of the label for the leading coefficient. So we've got plus or minus 1 and plus or minus 2. So the factors of the constant term are my possible numerator, and here the factors of the leading coefficient are the possible denominators. So if I'm using a denominator of 1, then I just go through the numerator, and 1 divided by 1, 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. Now I divide by 2, 1 divided by 2. 2 divided by 2 is 1, and I've already got that in there, so I don't need that. 3 over 2. 6 divided by 2 is 3, and I've already got 3 in the list. So here's my list of possible zeros. I don't know if any of them are actually going to turn out to be zeros of this function, but if the graph crosses the x-axis at a rational number, it'll be in this list. So let's come in and see if we can't find an x-intercept, a zero of this function. I'm going to use synthetic division. If you want to plug in numbers into the function and see where the output is 0, you can do that. But I'm using synthetic division because as soon as I find a 0, I'm going to have to use synthetic division anyway. Let's try 1. Well, I should have pointed out that I did look up at this, that this is in standard form. There's no greatest common factor. If there was a greatest common factor, I want to factor it out before I write down these factors of the constant term and the leading coefficient. So I have no missing terms like I did in that previous problem. I've got a 4th degree, 3rd degree, 2nd, 1st constant. So in my synthetic division, I've got 2, negative 1, negative 14, negative 5, and positive 6. First number always comes straight down. If it's below the line, it gets multiplied by that number in the box. So I do not get a 0 here. So hopefully I did my arithmetic. I know well enough that this is not 0. 1 is not an x-intercept. Let's check and see if negative 1 might be. I've got 2, negative 3, 3, negative 11, 11, 6, negative 6. Hey, we found 1. We're not always so lucky to find them at the beginning of our list. Some of you might be gifted enough with a number sense to be able to just kind of look at the list and be able to see which numbers are more likely to produce a 0 than others. Alright, so what does that tell us? That tells us that this 4th degree that we can factor this. Alright, so I know that this x minus 1 is a factor. Now, this is 2x cubed minus 3x squared minus 11x plus 6. I'm not going to be able to, I don't have an x method or any way to factor that. But if I look at 2 and 6, that was the same leading term, 2 and 6, is my original expression. If I consider this polynomial that's of 3rd degree, where it crosses the x-axis, has to be in this, if it's a rational number, has to be in this list. In fact, it could be negative 1 again. So now I want to come in and try various numbers in this list and see if I can find a 0 for this guy. I don't need this number. I'm through with that remainder. Alright, so let's try 1, I guess. We'll just go through the list. We'll pull down a 2, 2, -1, -1, -12, -12. Probably I shouldn't have bothered. It might have given me a 0 before when I tried. Since it didn't give me a 0 before, it's not going to give me 1 now. So maybe that was a waste of time to try 1 again. But let's see if -1 could be a repeated root. Let's see if it's also another, a factor here. Let's bring down 2, -2, -5, 5, -6, but then this is +6, and that's not 0, so -1 is not a factor, or excuse me, a 0. All right, so let's move on in the list and let's try 2. That's not 0, so 2 doesn't work, so let's try -2. And there we have one. Okay. So now I have it down to a quadratic, a 2x squared minus 7x plus 3. Maybe I'll have to use the quadratic formula. Maybe I can factor it. Maybe it's still in the list. Now, this time I notice that I still have a leading coefficient of 2, but my factor, instead of my constant term, instead of being 6, is now a 3. So it's just a smaller version of the same list with having factors of my constant term just being 1 and 3. Then I've got 1 over 1. I've got 2 is no longer of interest to me. 6 is no longer of interest to me. But 1 over 2 and 3 over 2, if this has, it might be one of these values. Well, we've already tried 1 and -1 before. We could look and see if 3 could be. I don't remember trying 3 in there, or we could look and try one of these fractions. So I could just write down 2x squared minus 7x plus 3 and use the quadratic formula and factor as normal, but I just want to see, I'm just curious if that's in our list here, which I believe it will be if we can just find it. Let's try 3. 2, 6, -1, -3. Hey, we found it. Okay, so what does this tell us? Well, it tells us this original function f of x in factored form, if -1 is an x-intercept in factored form, that's x plus 1. And if -2 is an x-intercept in factored form, that's x plus 2. If x equals 3 is an x-intercept, as 0 the function, in factored form, it's x minus 3. And the 2 and the -1 tell me I have 2x minus 1. So I'm getting zeros of this function, that this graph is crossing the x-axis. Well, intersecting, I don't know if it's a cross or a touch. Well, yes, I do. All of these are 1. So I know all of these are crossing, doing a cross at these zeros and not a touch and turn. So I've got -1, -2, +3, and x equals 1/2. I found 4 x-intercepts, and this was of degree 4, my original function, so I found all of the zeros, and fortunately they were all rational numbers, and everything worked out real nicely with this theorem. So I hope that helps.